Everyone, our last page on this midterm review packet. This is called the short answer section, even though all of them were basically short answer questions. However, on the midterm, you're going to have several multiple choice and then a few short answer that are going to look like the questions we're about to go over on this last page. So let's get started. Solve the system of equations using any method. Show all of your work. So we've looked at some other problems with systems of equations, and we've talked about 3 different methods: graphing, substitution, and elimination. Usually we don't use graphing, especially if we don't have a graph around. So substitution and elimination are our 2 favorite methods to do this algebraically. I'm going to walk through both with this problem, just so that you get more practice. So let's take a look at what we have. 3x minus 5y equals 15. And x minus 4y equals 12. The first method I'm going to use is elimination, where I get rid of one variable. Now, in order to do that, you have to think about which variable you want to get rid of, either the x's or the y's. Now, when I look at the x's, I have a 3x and I have a positive x. And I think to myself, 3x should cancel out with a negative 3x. I could multiply the entire bottom equation by negative 3 and get rid of the x's that way. My other option is to look at the y's, negative 5y and negative 4y. Well, in order to get rid of those, we'd have to have the same coefficient, just opposite signs. So I would have to do the lowest common multiple of negative 5 and negative 4. So I'd multiply the top by a 4, and then I'd multiply the bottom by a negative 5, and that way we'd have 20 as our coefficient, positive and negative 20. That's a lot more work. So I'm going to go with the x's, and I'm going to get the x's to cancel out, to eliminate. So in order to do that, I'm not going to touch the first row, and I'm going to try and get the bottom row to have negative 3 as the coefficient to x. So in order to do that, I'm going to go ahead and zoom in, and I'm going to multiply everything in the bottom equation by negative 3. So multiply every term by negative 3. This way, you're not changing the value of the equation, you're just manipulating it by using the multiplication property of equality. So, as a result, if I multiply everything by negative 3, I'm going to get negative 3x. Negative 3 times negative 4 is a positive 12y. And then 12 times negative 3 is negative 36. I'm going to bring the top equation over. So I have 3x minus 5y equals, oh, I forgot the equal sign here, equals 15. Now the goal was so that I have these 2 x values cancel out when I add. I'm going to add vertically. So they're stacked up, 3x minus 3x, those are going to cancel. That was the goal, to make them cancel. Now I have negative 5 plus 12, which gives me 7y positive equals 15 minus 36. I'm going to have a negative, and now let's figure out what negative I'm going to have. 36 minus 15. 5 minus 6 is 1. 1 subtracted from 3 is 2. So I'm going to have a negative 21. Next step, I'm going to divide both sides by 7 so that I could solve for y. Notice I only have y's now. So it's an easy 2-step, 1-step equation. The 7's cancel, so y is equal to a negative 21 divided by 7, which is 3. Negative 3. Now that I have negative 3, I'm going to go ahead, I'm going to plug it into either the top equation or the bottom equation, whatever I want, and it's going to give me the value of x. So I'm going to go ahead, I'm going to plug it into the bottom equation. It looks a little simpler since there's no coefficient to x. So remember, I'm going back to the originals. So I'm going to plug in x minus 4y equals 12. I'm plugging in negative 3. So now I'm going to have x minus 4 times negative 3 equals 12. X, negative 4 times negative 3 is a positive 12, equals 12. Subtract 12 from both sides. Those cancel. And now I have x equals 0. So my x value is 0 and my y value is negative 3. So the answer here is 0, comma, negative 3. This is using elimination. Now let me show you how you would do it using substitution. Okay, so now doing substitution. When I want to do substitution, I want to solve for one of the variables, either x or y. And I could choose either the top or the bottom equation, it doesn't matter. I'm going to use the bottom equation because it seems like I can solve for x pretty easily. I can isolate the x value pretty easily. Now, in order to do that, I'm just going to use my normal solution methods. So I'm going to get rid of the negative 4y by adding 4y to both sides. So now I have x equals 4y plus 12. So anywhere I see an x now, I'm going to put 4y plus 12. So I'm going to go ahead and I'm going to use this top equation now. Since I converted the bottom one, I have to use the other equation now. And I'm going to substitute in 4y plus 12 for where there's an x value. So 3, I'm going to plug in 4y plus 12 minus 5y equals 15. So the only thing I did was I plugged in that 4y plus 12 wherever there was an x. Now we can go ahead and we can solve for y because I only have y as a variable in this equation. So let's distribute the 3. 3 times 4y is 12y. 3 times 12 is 36 minus 5y equals 15. Combine like terms, 12y and negative 5y gives me 7y plus 36 equals 15. We're going to subtract 36 from both sides. And we're going to be left with 7y equals 15 minus 36. So it's going to be a negative, and we've done this before. 36 subtract 15 leaves you with 21. Divide both sides by 7. Y equals negative 3. So now that I have the y value, all I need to do is plug it in to either equation, and I can solve for x. So I'm going to use that bottom equation just because it looks simpler. So I'm going to do x minus 4 times negative 3 plus 12. So x, oh, not plus 12, sorry. Should say equals 12. So x plus 12, because negative 4 times negative 3 is a positive 12, equals 12. Then when I subtract 12 from both sides, I get x equals 0. Same as I did before. My final answer is 0, negative 3. Now, back here, I didn't have to plug it in to the original equation. I could have used what I had right here where it says x equals something and plugged it into there. So I could have done x equals 4 times negative 3 plus 12 and still gotten the same answer. Negative 12 plus 12 would still give me 0. Okay. So to recap, using the substitution method, you pick either of the two equations when you start to solve for a single variable. I chose to solve for x because x didn't have a coefficient, and it was going to make it quicker. So x was now equal to 4y plus 12. So I used the other equation, the top, the one highlighted in blue, I used the other equation to plug in x, and then I solve this equation for the value of y. Having y, now I can plug it back in to either of the two equations that we started with, or with what we converted the bottom equation into, and solve for x. All right, so those are two methods. First we did elimination, then we used substitution. Let's move on. Number 2. David makes $7 per hour babysitting and $14 per hour giving music lessons. One weekend, he worked a total of 15 hours and made $126. How many hours did he spend babysitting? How many hours did he spend giving music lessons? Okay, let's go back to the beginning and let's organize our information. So David makes $7 per hour babysitting. So the way I'm going to express that is I'm going to say 7 times, because we use the word per for when we want to say times. So 7 times the hours he spent babysitting. So the letter B stands for the hours he spent babysitting. Okay, it stands for this right here. And $14 per hour giving music lessons. So now $14 per hour giving music lessons. Again, per. So now we have 14 times the number of hours giving music lessons. I'm going to use the letter M. So that's going to give me the number of hours that he's giving music lessons, M, times 14. One weekend, he worked a total of 15 hours. So the number of hours that he worked in total was 15. Let's think about what here represents the number of hours that he spends babysitting and giving music lessons. Remember, the letters themselves, B stands for the number of hours babysitting. M stands for the number of hours giving music lessons. So one weekend, B plus M, the number of hours babysitting and the number of hours giving music lessons, together was equal to 15 hours. So remember, the individual letters B and M stand for the number of hours, and together the number of hours was equal to 15. Now, the other piece of information they give you is they said that he made $126 doing it. So now we're thinking about the actual price, the dollar amount that he was receiving. So now we're going to go ahead and take a look at the 7 and the 14. So 7 is the amount that he makes per hour babysitting. 14 is the amount that he makes per hour giving music lessons. And whatever the amount of the hours of babysitting and music lessons, together, when he added those two values together, he ended up making $126. So the 126, because it's the monetary amount, has to do with the 7 and the 14. So the second equation that we have going on here is $7 per hour babysitting plus $4 per hour giving music lessons earned him a total of 126 hours. This is a system of equations. The question is, how many hours did he spend babysitting? In other words, what is B equal to? And then how many hours did he spend giving music lessons? In other words, what is M equal to? So they're asking you for B and they're asking you for M. In order to do it, you have to use the system of equations. Now, let's pick one method to use. The method that I'm going to use here is going to be, let's do substitution. Okay, so substitution. I'm going to pick the top equation and I'm going to solve for one variable. So let's go. I'm going to have B plus M equals 15. I'm going to, let's say, solve for b. So I'm going to subtract m from both sides. And now b equals negative m plus 15. So anywhere that I see a b value, I'm actually going to plug in negative m plus 15. Now, where do I do that? I do that now with the second equation. Now that I've converted the first equation, I'm going to plug into the second equation. So let's go ahead and do that. So now it's going to be 7 times negative m plus 15 that should say plus. Let me fix that. Plus 14m equals 126. Now that this entire equation has been converted into something that only has m, I can solve for the variable m. Let's go ahead and do it. So I'm going to distribute the 7 to both terms. 7 times negative m is negative 7m. 7 times 15, let's go ahead and work it out. A little technical difficulty. Seven times 5 is 35. 7 times 1 is 7, plus 3 is 10. So 105. So I'm going to have plus 105 plus 14m equals 126. Combine like terms. So I have a negative 7m plus 14m, which is going to give me a positive 7m plus 105 equals 126. Subtract 105 from both sides. Give myself some room. Now I'm going to do 126. Do it on the other side here. Okay. 126 minus 105. 5 minus 6 is 1. 0 subtracted from 2 is 2. 1 subtract from 1 is 0. So it's 21. 7m equals 21. Divide both sides by 7. So m is equal to 3. So that means he spent 3 hours giving music lessons. Remember, m stands for the number of hours giving music lessons. All right, so we have our first ask. The answer here is 3. 3 hours giving music lessons. Now we have to figure out the number of hours babysitting. So let's go ahead. Let's go back to here where we said b, the number of hours babysitting, is equal to negative m plus 15. So let's go ahead and solve by plugging in for m now that we know what it is. So negative 3 plus 15. So b is going to be equal to negative 3 plus 15, which is 12. So we have, in this problem, 12 hours spent babysitting, 3 hours spent giving music lessons. So b is 12, m is equal to 3. And together, the number of hours is 15 hours that he spent working in total. All right, so the key for this question is that you set up 2 different equations. One equation that talked about the actual money earned. So that was 7 times b, 14 times m, added together gives you the total amount of money that was earned. And the second equation is talking about the number of hours, the variables themselves. That number of hours for b plus the number of hours for m gives you a total of 15 hours. 2 separate equations gave us a system of equations that we then solved. All right, let's go on to number 3. Number 3, simplify the expression. Okay, There's a lot going on there, so take a moment, just look through it. All right, so let's zoom in and let's work through it so we can try and get rid of as many of these parentheses and brackets that we can. All right, so 7x plus 4 times. 4 times. 4 is going to multiply by this entire thing inside of this parentheses. So before I can multiply the 4 into the parentheses, I need to see if there's something inside of the parentheses that I can simplify. So we're going to get to the yellow later. Let's take a look inside of that yellow section and see what we can try to simplify there. I have parentheses inside of the bigger parentheses. So I have this set of parentheses here, and then I have this set of parentheses here. I would like to get rid of the parentheses if possible. In order to do that, I'm going to have to distribute the negative to both terms inside the yellow parentheses. And then I'm going to have to distribute the positive 2 to both terms in the blue parentheses. And that's going to simplify things a little bit for me. So to get started, I'm going to copy down everything except for what's going on in here. And we're going to work with that. Okay, so 7x plus 4. Big bracket area here. All right. The negative gets distributed to both terms in the parentheses. So it's going to change the sign of both terms. So now we're going to have negative 3x minus 1. And now with the blue brackets or the blue parentheses, positive 2 times x is plus 2x. Positive 2 times negative 2 is a negative 4. Okay, so now everything inside of here looks a little bit cleaner, but I can still combine some terms here. All right, so rewrite everything else. So let's combine like terms. I have negative 3x and positive 2x. So I'm going to combine those. I get a negative x. Then I have a negative 1 and a negative 4. Negative 1 minus 4 is negative 5. Okay, much cleaner. So now these brackets are going to act like parentheses. And so now I'm going to distribute the 4 that's in front of the parentheses to the negative x and to the negative 5. So distribute it to the negative x and the negative 5. So 7x positive 4 times negative x is a negative 4x. Positive 4 times negative 5 is negative 20. Give myself a little room to write. Let's go ahead. Next step. Much cleaner now. 7x minus 4x. 7 minus 4 is 3x. And minus 20 has nothing to combine with. So my final answer here, in simplest form, is 3x minus 20. Okay, not that bad. So remember, we distributed the negatives first, all the way inside the parentheses, and the positive 2, we distribute all of that. We combined like terms at the next step that were inside the parentheses. Then we started to distribute the positive 4, and then we simplified last step. Not bad. Let's go on to the next problem. Number 4. Fill in the blanks with the correct reason to complete each step of the proof. Okay, so first statement. 3 times f minus 5 equals 6. Well, that's given to you. All right, next step. 3f minus 15 equals 6. Well, notice the parentheses are gone. So somebody distributed the 3 to the f and 3 times the negative 5 to get 3f minus 15 equals 6. So this is the distributive property of equality. So I'm going to write PO, property of equality. All right, next step. 3f minus 15 equals 6 turns into 3f equals 21. So notice the negative 15 goes away. How does it go away? Well, somebody must have added 15 to both sides. This would cancel out the negative 15, so you'd be left with 3f equals 6 plus 15, which is 21. So 3f equals 21. So what happened to get from the previous step to 3f equals 21? The addition property of equality. You added. So addition po. And the last step now. 3f equals 21 turns into f equals 7. So what went away was the 3 in front of the f. How do we get rid of it? Well, we divide it out. So both sides had to be divided by 3. This way the 3's cancel. 21 divided by 3 is 7. So what happened here was the division property of equality. Division po. Okay. And that finishes that. We went step by step and figured out what happened, and that was the name of our property. Let's go ahead to the last question in this packet. Last question, number 5, word problem. The price of renting a trampoline park for a party is $785 as a flat fee, and then $12 for each person who attends. The most you can spend on the party is $1,290. Write an inequality to model this situation. This is our ask. Write an inequality to model what's happening here. You don't have to solve it. You just have to write it. And the fact that it says inequality means you're going to be using less than or greater than symbols. All right, let's take a look. The price of renting a trampoline park for a party. That doesn't really help us yet. $785 as a flat fee. So you have to start with $785. So I'm going to write down $785, no matter what. And, so I'm going to add to that, and then $12 for each person who attends. So $12 per person, each person. So the number of people times 12 is going to be the cost for the people. So I'm going to have 12 times the number of people who attend. I'm going to give it a variable because I don't know who's attending. And I'm going to say P. So 785 plus 12 times P, 12 times the number of people, is going to give me the cost. All right. Now, it says the most you can spend is $12.90. The most. So the cost of the party cannot go above $12.90. So can you spend $12.90? Yes, you can. You can spend the most $12.90. But really, you need to spend less than that. So most likely, you want to spend less than that. So what this inequality should say is that 785 plus 12p is less than $12.90 or equal to. Less than or equal to. So if I want this to be less than or equal to, I'm going to use the less than or equal to symbol, which looks like this. Less than or equal to. So remember, we talked about this in some earlier questions. This symbol, less than or equal to, is sometimes referred to as the most. Okay? Less than or equal to. So our final answer is simply 785 plus 12p is less than or equal to 1290. Writing it with the variable first would simply look like 12p plus 785 is less than or equal to 1290. And that is our final answer. Because all they want is the inequality. They don't want us to have to solve for anything. We don't know how many people are coming. Okay. So we are done. Congratulations. Make sure that you are reviewing through everything in this packet. If you can do everything in here without any problems, you're ready to go for your midterm. Make sure you've practiced this packet again without any distractions, without any notes, not even this video, and see if you can do the problems by yourself. If you can, then you're ready. Good luck.